Hello students, today we will be seeing a relation and function NCERT exemplar problems. A small disclaimer, the images, text and other materials used in our presentations are for educational purposes only. We respect the intellectual property rights of the original creators and owners. If you are the owner and have any concerns or issues, please contact us at SATHEE@itk.ac.in and we shall remove the content immediately. Please note that the parts of the content may have been generated using generative AI, which is an experimental. Here's our question. So this question, in this we are having two sets. Set A with 3 elements -1, 2, 3. Set B with 2 elements 1 and 3. We are required to find out Cartesian products A cross B, B cross A, B cross B and A cross A. You'll have some seconds to try this problem, then afterwards we will move on to the solution slide. So your time starts now. The time is up. Now, in question, we are given with two sets A and B, and we have to find out the following Cartesian products: A cross B, B cross A, B cross B, C, A cross A. Solution. So A set with 3 elements -1, 2, 3. B set with 2 elements 1 and 3. A cross B by definition is a collection of ordered pairs such that the first position of your ordered pair is from set A and second position is from set B. So we are having -1, 1, -1, 3, 2, 1, 2, 3, 3, 1 and 3, 3. Total 6 pair in A cross B. In B cross A, now collection of all ordered pair, the position of first filled by set B elements and second position of your ordered pair filled by the set A elements. So you are having your 6 ordered pair as 1 -1, 1, 2, 1, 3, 3, -1, 3, 2, 3, 3. Now for B cross B, both your elements first position and second position are coming from where? Set B. So you will have 4 ordered pairs 1, 1, 1, 3, 3, 1, 3, 3. Now for A cross A, you'll have 9 ordered pairs and both the positions filled by the set A elements -1, -1, -1, 2, -1, 3, 2, -1, 2, 2, 2, 3, 3, -1, 3, 2 and 3, 3. Clear? Now this question. Suppose set P in set builder form is described as collection of all x. X must be less than 3 and x belongs to the set of naturals. There is another set Q in set builder form described as collection of all x, x less than equals to 2 and x belongs to the set of whole numbers. So W represents set of whole numbers. Now find P union Q cross P intersection Q. Clear? You will have some seconds to try this problem. Then afterwards we will move on to the solution slide. So your time starts now. The time is up. Question is very simple. P and Q sets are defined in set builder form and we have to find out the Cartesian product between P union Q and P intersection Q, where this W represents the set of whole numbers. Solution. We are given with P set, collection of all natural numbers less than 3. Q set, collection of all whole numbers less than equals to 2. So roster form P set will be 1, 2, and a roster form for Q set is 0, 1, 2. Clear? Now P union Q is simply collection of all elements which either belongs to set P or to set Q, or if they are belonging to both set, you can collect. Now for P intersection Q, collect all those elements which are common to both. In this case, 1 and 2 are the only elements which are common to both. Now we are having our P union Q set and P intersection Q set. Now you can easily apply your A cross B definition. So A cross B, in this case P union Q cross P intersection Q gives you what? Simple ordered pairs in which the first element belongs to the set P union Q and second element of your ordered pair belongs to the set P intersection Q. So 0, 1, 0, 2, 1, 1, 1, 2, 2, 1 and 2, 2. You will have 6 ordered pairs. Clear? Moving to next. This question. Set A, described as collection of all whole numbers strictly less than 2. Set B, collection of all natural numbers strictly greater than 1 and strictly less than 5. C set, given in roster form. So C set, you are having 2 elements 3 and 5. You have to find out these 2 Cartesian products, A cross B intersection C and A cross B union C. You will have some seconds to try this problem, then afterwards we will move on to the solution slide. So your time starts now. The time is up. In this question, we are given with 2 sets, 3 sets actually, 3 sets. Out of 2 are in set builder form. So A described in collection of all whole numbers which are strictly less than 2, and B set collection of all natural numbers which are greater than 1, strictly greater than 1 and strictly less than 5. C set in roster form 3, 5. Just find out 2 Cartesian products, A cross B intersection C and A cross B union C. Solution. What we have? Set A, collection of all whole numbers is strictly less than 2. In roster form, we are going to have 2 elements 0, 1. Set B, collection of all natural numbers greater than 1 and less than 5. So we are going to have 3 elements 2, 3, 4. C set already given to us 3, 5. Now for first we have to solve for this bracket B intersection C. Now B intersection C set is collection of all elements which belongs to both set B and C. So we are having only one element which is 3 which belongs to the both set. So B intersection C will be your singleton set with element 3. Now A cross B intersection C is simply your collection of all ordered pair in which the first position of your ordered pair filled by A elements and second position filled by B intersection C set elements. So we are going to have total 2 ordered pairs 0, 3, 1, 3. Now for second, A cross B union C. First, find out B union C. So B union C is your set in which you have to collect all your elements from set B as well as from C. So collecting all the elements from B and then from C. So you will have this set with 4 elements 2, 3, 4, 5. Now A cross B union C, collection of all ordered pairs in which the first position of your ordered pairs filled by A elements and second position filled by B union C set elements. So you will have how many ordered pairs? 8 ordered pairs. 0, 2, 0, 3, 0, 4, 0, 5, 1, 2, 1, 3, 1, 4, 1, 5. Clear? Moving to next. This question. What we have to do is find out the values of A and B. We are given with that this ordered pair 2A plus B, A minus B is same as 8, 3. And in second, we are given with that A by 4, A minus 2B, this ordered pair is same as 0, 6 plus B. You will have some seconds to try this problem. Then afterwards, we will move on to the solution slide. So your time starts now. The time is up. Solution. Quite simple. As we are given that this left hand side ordered pair is same as the right hand side ordered pairs in both parts, first and second. We have to find out A and B. How we are going to do that? Quite simple. Just recall the definition or the condition when we say that 2 ordered pairs are actually the same. We say when the first position of your left side ordered pair is same as the first position of your right side ordered pair, and also the second position of your left side ordered pair is same as the second position of your right side ordered pair. Then we are going to say that the given 2 ordered pairs are the same. Solution. We have 2A plus B, A minus B ordered pair same as 8, 3. So using the condition, we are going to have 2 equations, 2A plus B is equals to 8 and A minus B is equals to 3. Since 2 ordered pairs are equal, their corresponding first and second elements are also equal. Now on substituting, B is equals to A minus 3 in the equation 2A plus B is equals to 8. We get 2A plus A minus 3 which is equals to 8. This gives me 3A minus 3 is equals to 8. So further 3A is equals to 11 and this implies A is equals to 11 by 3. So A value is 11 by 3. Now we have A value. Now just substitute this A value in the equation B is equals to A minus 3. We are getting B is equals to 11 by 3 minus 3 which is 2 by 3. So A is 11 by 3 and B is 2 by 3. Simple. Now for second part, we are given with ordered pair A by 4, A minus 2B is equals to 0, 6 plus B. Now, what we are having? simply this first position must be same as the corresponding first position. So A by 4 is equals to 0. Gives me A must be 0. And A minus 2B is equals to 6 plus B. As we have A is equals to 0. So just substitute A here and we are getting 0 minus 2B is equals to 6 plus B. Gives me minus 3B is equals to 6. Gives me B is equals to minus 2. Therefore, A is 0 and B is minus 2 in this case. I hope the solution is clear. Moving to next. This question. Given set A with 5 elements 1, 2, 3, 4, 5. Set S in set builder form. Collection of all ordered pairs x, y such that x and y both belongs to the set A. Then find the ordered which satisfy the conditions given below. So first, x plus y must be 5. Second, x plus y must be less than 5. And in third, x plus y must be strictly greater than 8. So we have to find such ordered pairs following the conditions. You'll have some seconds to try this problem. Then afterwards, we will move on to the solution slide. So your time starts now. The time is up. So in question, we are having set A with 5 elements 1, 2, 3, 4, 5. Set S in set builder form collection of all ordered pairs where x and y both belongs to set A. And we have to find out ordered pairs following the given condition. So for first, find out ordered pair satisfying x plus y is equals to 5. Find out ordered pair satisfying x plus y strictly less than 5. Find out ordered pair satisfying x plus y strictly greater than 8. Solution. We are given with set A with 5 elements 1, 2, 3, 4, 5. Set S in set builder form collection of all ordered pairs such that x and y both belongs to set A. So the set of ordered pairs satisfying the first condition x plus y is equals to 5 is, so simply the set is ordered pairs 1, 4, 2, 3, 3, 2 and 4, 5. As we are having the sum as 5. Now for second, the set satisfying the condition x plus y is less than 5 is, so we are having ordered pairs 1, 1, the sum is 2, strictly less than 5. 1, 2, sum is 3. 1, 3, sum is 4. 2, 1, sum is 3. 2, 2, sum is 4. 3, 1, sum is 4. Now for third, the set of ordered pairs satisfying the condition x plus y strictly greater than 8. So 4, 5, sum is 9. 5, 4, sum is 9. 5, 5, sum is 10. I hope the solution is clear. Moving to next. This question. Is G in a roster form given to us in roster form 1, 1, 2, 3, 3, 5, 4, 7 a function? Is the given relation G a function? Justify your answer. If this is described by the relation Gx is equals to alpha x plus beta, then what value should be assigned to alpha and beta? You'll have some seconds to try this problem. Then afterwards we will move on to the solution slide. So your time starts now. The time is up. So in question, we are given with G in a roster form, some collection of some ordered pairs, 4 ordered pairs actually. So we have to answer, is this G a function, and justify it. If this described by the relation gx is equals to alpha x plus beta, then what value we should assign to alpha and beta in order to get the same ordered pairs collection? Solution. We have the given set G with ordered pairs 1 1, 2 3, 3 5, 4 7. Since a relation F from set A to B is said to be a function if every element of set A has one and only one image in a set B. So G is a function. Now Gx is equals to alpha x plus beta when x is 1. G1 is going to be alpha times 1 plus beta, meaning 1 is equals to alpha plus beta. So this is our equation 1. Up till now what we have seen is G is a function. Why? Because it is satisfying the condition. Now in order to get the alpha and beta value, we are going to get help from these ordered pairs. If you give input 1, the output is also 1. So using the relation, we are giving input 1 and getting output 1. So we are having this as our equation, alpha plus beta must be 1. Now if input is 2, then G2 is equals to alpha times 2 plus beta by using the relation. The output is, input is 2, output is 3. So 3 is equals to 2 alpha plus beta. Now we are having another equation, say 2. Now solve both the equations. We get alpha as 2 and beta as minus 1. So we are having alpha 2, beta minus 1. Simple steps, simple approach. I hope the explanation is clear. Moving to next. This question. We have to find out domain of the each functions given to us. So we are given with 5 functions. Fx is, first one is fx is 1 by root 1 minus cos x. Second one is 1 by root x plus absolute x. Third one is x times absolute x. Fourth one is x cube minus x plus 3 by x square minus 1. And fifth is 3x by 2x minus 1. You will have some seconds to try this problem, then afterwards we will move on to the solution slide. So your time starts now. The time is up. Moving to next. So 5 functions are given to us and we have to find out the domain set. So recall, what is your domain? So collection of all inputs. Yes, collection of all inputs will be your domain set. Solution. For first, fx is 1 by root 1 minus cos x. We know that this cos x is greater than equals to minus 1 and less than equals to 1. Clear? This is already we have known. Now, multiplying with minus 1 to every side, we are getting the inequality minus 1 less than equals to minus cos x less than equals to 1. Now, just what we are doing, just adding 1 to every side. We are getting -1 plus 1 less than equals to 1 minus cos x less than equals to 1. So 0 less than equals to 1 minus cos x less than equals to 1. Simple. Now fx is defined when denominator is non-zero. So 1 minus cos x must be non-zero. We know. So we are getting the condition that cos x must not be 1. And we know for what values of x it is 1, x. So x cannot be multiple of 2 pi. Simple. Where n belongs to the set of integers. Therefore, domain is simply going to be what? All real numbers except the numbers 2 n pi, where n belongs to set of integers. Clear? I hope the domain explanation for first is clear. What we did is quite simple. First condition, that denominator cannot be 0. So we are getting x cannot be 2n pi. Clear? Now, are we having 1 minus cos x negative value? No. Why? We know that cos x always belongs to the interval -1 to 1. Yes, so this input is always be positive or some 0. But we are excluding whenever it is 0. So we are getting the domain as all real number except 2 n pi numbers. Now, for second function, fx is 1 by root x plus absolute x. So just break this down, that x plus mod x is actually x minus x when x is negative, which is 0. X plus mod x is 2x when x is greater than equals to 0. So we broke this expression into piecewise function. Clear? Now, as this x plus mod x is 0 whenever x is negative, hence fx is defined if x is positive. Simple. Fx is defined when x is positive. Why? Because for any negative, the denominator gets 0. But we do not want our denominator to be 0. So we are excluding all such numbers where the denominator becomes 0. So excluding all negative numbers, we are only left with non-negative numbers. Now in non-negative numbers, we are having 0. If you plug 0 here, 0 plus 0 still 0. So we are also excluding 0 from the domain set. So we are getting domain as R positive, meaning all positive real numbers. Simple. Now, for third, the function is x times mod x. Clearly, we are having no restriction on x. We can use any real number over here. So fx is defined for any real number. So domain is the complete set of reals. Now, the fourth, fx defined by x cube minus x plus 3 by x square minus 1. Fx is not defined whenever denominator becomes 0. So we are looking for such points when denominator is 0. So denominator is x square minus 1, and solve this equation. X square minus 1 is equals to 0. We are getting the factor form x minus 1 times x plus 1 is equals to 0, which gives me two such values where denominator becomes 0. So excluding these two numbers from the set of reals, because you can plug any real numbers except these. So these are the only condition, restriction. So input is any real number except these two numbers. So domain set is all real number except -1 and 1. Simple. Now fifth function is 3x by clearly fx is defined if 28 minus x is not equals to 0. Is not equals to 0. So what we want is x cannot be 28. So domain is simply all real numbers except 28. Simple. Except 28. Moving to next. Now this question. The range of the following functions given by, so we have to find out range. Fx is 3 by 2 minus x square. Fx is 1 minus mod x minus 2. Fx is mod x minus 3. Fx is 1 plus 3 cos 2x. You'll have some seconds to try this problem. Then afterwards we will move on to the solution slide. So your time starts now. The time is up. This question. So what we have to find out is a range of the given four functions. Solution. We have fx is 3 by 2 minus x square. Assume fx is equals to some y output. Now y is equals to 3 by 2 minus x square. So 2 minus x square is equals to 3y, which gives me x square is equals to 2 minus 3y. Imply x is equals to root of 2y minus 3 by y. Now 2y minus 3 divided by y must be greater than equals to 0. So first find out some critical points. So numerator, so how we are going to do that? Quite simple. In order to find out critical points, just solve for numerator when numerator is 0 and denominator is 0. So for numerator we are getting y as 3 by 2 and denominator we are getting y as 0. Now critical points, split the real number line into intervals. What are these intervals? Y less than 0, y greater than 0 less than 3 by 2 and y strictly greater than 3 by 2. Now for y negative or less than 0, the numerator is negative and denominator is also negative. The actual output, numerator by denominator both negative, gives me positive output. Now for y greater than 0 less than 3 by 2, numerator is negative, denominator is positive. So numerator by denominator is going to be negative, but we want our expression to be positive. So we are going to ignore these values. Now for y greater than 3 by 2, numerator is 2y minus 3 greater than 0, which is positive, and denominator is also positive, meaning numerator by denominator output is positive. So now checking for endpoint. So y0 denominator is 0, so undefined. We do not want our denominator to be 0. Now for y is equals to 3 by 2, the numerator is 0. So 0 by 0 we are getting, so which is defined. So the range of our function f is simply open interval minus infinity to 0 union interval closed at 3 by 2 open at infinity. Simple, very easy approach. Moving to next. Now for second, fx is 1 minus mod x minus 2. We have absolute of x minus 2 greater than equals to 0. Imply minus of absolute x minus 2 less than equals to 0. Imply 1 minus absolute x minus 2 less than equals to 1. Imply fx, this is your what? Fx is less than equals to 1. Therefore range is simply interval open at minus infinity closed at 1. Clear? Because your output value is always less than or equal to 1, and range is collection of all your outputs. Now for third, fx is absolute of x minus 3. We know that absolute of x minus 3 is always greater than equals to 0. This implies this is your what? Fx. So fx, which is your output, is always greater than equals to 0. So range of f is simply all non-negative real numbers, or in interval closed at 0 open at infinity. Now for fourth, fx is 1 plus 3 cos 2x. We know minus 1 less than equals to cos 2x less than equals to 1. This gives me, multiplying with 3, we are getting minus 3 less than equals to 3 cos 2x less than equals to 3. Gives me 1 minus 3 less than equals to 1 plus 3 cos 2x less than equals to 1 plus 3. Imply minus 2 less than equals to 1 plus 3 cos 2x less than equals to 1 plus 3. And this is your what? Fx, your outputs. So your output is greater than equals to minus 2 and less than equals to 4. So range is simply closed interval minus 2 to 4. Now this fx is absolute of x minus 2 plus absolute of 2 plus x, where x is greater than equals to minus 3 and less than equals to 3. What we have to do is simply redefine it, meaning we have to write this function in piecewise terms, piecewisely. You'll have some seconds to try this problem, then afterwards we will move on to the solution slide. So your time starts now. The time is up. So fx is absolute x minus 2 plus absolute 2 plus x, where x is greater than equals to minus 3 and less than equals to 3. Solution. So first of all, break this term absolute of x minus 2. So absolute of x minus 2 is minus of x minus 2 when x is less than 2, and absolute of x minus 2 is x minus 2 when x is greater than equals to 2. Now for this term, absolute of 2 plus x. So absolute of 2 plus x is minus of 2 plus x when x is less than minus 2. And absolute of 2 plus x is 2 plus x when x is greater than equals to minus 2. So given that fx is absolute of x minus 2 plus x absolute, where x is greater than equals to minus 3 and less than equals to 3. So fx simply, so we are having 3 pieces for first piece, x is greater than equals to -3 less than -2. So for these values of x, this is going to be minus of x minus 2, and this term is going to be minus of 2 plus x. For these values x greater than equals to -2 and less than 2, fx is going to be minus of x minus 2 plus 2 plus x. And for these values of x greater than equals to 2 less than equals to 3, fx is x minus 2 plus 2 plus x. So now just simplifying, we are getting fx as minus x plus 2 minus 2 minus x for x greater than equals to -3 less than -2. fx is minus x plus 2 plus x for x greater than equals to -2 less than 2. And fx is x minus 2 plus x for x greater than equals to 2 less than equals to 3. So fx is minus 2x for x greater than equals to -3 and less than -2. fx is just 4 when x is greater than equals to -2 and less than 2. fx is twice of x when x is greater than equals to 2 and less than equals to 3. Simple. Now this question. If fx is x minus 1 divided by x plus 1, then show that f of 1 by x is minus fx and f of minus 1 by x is minus 1 by fx. You will have some seconds to try this problem, then afterwards we will move on to the solution slide. So your time starts now. The time is up. So quite simple. fx already given to us, x minus 1 divided by x plus 1. What we have to show? For first, f of 1 by x is minus fx and f of minus 1 by x is minus of 1 by fx. Solution. We have fx as x minus 1 by x plus 1. So for first, f of 1 by x is simply, so for each input x, the output is x minus 1 divided by x plus 1. Now for each input 1 by x, the output is 1 by x minus 1 divided by 1 by x plus 1. Simplified. Numerator becomes 1 minus x divided by 1 plus x by x. X going to be cancelled. We are getting 1 minus x divided by 1 plus x. Taking minus common from the numerator, we are getting minus of x minus 1 divided by x plus 1. And this expression is simply fx, so we are getting minus of fx. Now for second, so starting with f of minus 1 by x. So for input minus 1 by x, the output is minus of 1 by x minus 1 divided by minus 1 by x plus 1. Numerator becomes minus 1 minus x by x divided by minus 1 plus x by x. So x will be cancelled. We are getting numerator as minus of x plus 1 divided by x minus 1, which is simply minus 1 divided by, so just observe that minus 1 divided by fx is nothing but minus 1 divided by fx is x minus 1 divided by x plus 1. So x minus 1 divided by x plus 1, rearranging the terms, we are getting minus of x plus 1 divided by x minus 1. This term and this term both same. So we are getting f of minus 1 by x is same as minus of 1 by fx. Simple solution. I hope it is clear. So this is it from this session. Thank you.